And so the first question asks you to find all of the factors for the numbers below. What is a factor, Zyla?
It is something you can times to get that number.
It's whole numbers greater than 1 that multiply together to equal a number. So if I'm looking for the factors of 53, I'm looking for all the numbers that I can multiply together to equal 53. What are we going to start with? What's the very first set of factors?
1.
1 times what? 53. 1 and 53. So on yours, you'll need to check both 1 and 53. Will 2 be a factor of 53?
No.
Why not? Why not, Bryce?
Start with the 2 or 0.
Okay. What do they have to end with? What?
An even number.
An even number. Yeah, it should have an even number in the ones place. That's how we know if a number has a factor of 2 or not. And since 3 is not even, we know 2 will not be a factor. How can I test to see if 3 is a factor of 53?
6 times 3 times 10.
Okay.
3 times 20.
All right, we know that 3 times, Bryce says 3 times 20. What is 3 times 20?
6.
3 times 20 is 60. That's a little bit more than 53. So I can go back to 3 times 19 is going to be what?
57.
57. 3 times 19 is 57. That's still a little more.
Take back another 3.
So if I go 3 times 18, that'll be 3 less, which is
54.
54.
Which you already know is not correct.
Yeah, so we know that that can't be correct. Why is that not going to be a factor?
Because
It's 1 away.
Yeah, 54 is 1 away from 53, which is the product we're looking for.
So it would be incorrect.
So it would not,
3
you're right.
51,
it would not be a factor. So I know 3 is not a factor. How about 4? How can I find out if 4 is a factor or not?
4 times 12.
Okay, Bryce says 4 times 12. 4 times 12 is equal to 48. Okay, so if I need a little bit more. So if I go up and do 4 times 13, that's 52. So that's 1 away. So that would not work. Okay. How about 5? Will 5 be a factor of 53?
There's not the 5 or 0. That's what I was talking about.
Okay. There's got to be a 5 or a 0 in the ones place for 5 to be a factor. Okay, Tatum said she noticed that 6 wasn't even an option, but we can go ahead and try 6 to make sure that 6 is not a factor.
6.
I know. Okay, Bryce says 6 times 10. That's equal to 60.
54.
So if we go back, 6 times 9 is what, Bryce?
54.
54. That's 1 away, so we know that 6 will not be a factor. How about 7?
Nope.
What can we multiply 7 times that would be close, Jeremiah?
8.
All right, so what is 7 times 8?
Wait.
Yeah, 7 times 8 is 56. And what were you saying, Bryce? 7 times 7 is 49. 53 falls right in between those. So we know that 7's not a factor. Jeremiah just said 8. 7 times 8 was 56, so we know that won't work. How about 9? Is 9 going to be a factor?
No.
Oh, we found a while ago that 6 times 9 is 54. That's 1 away. Is 10 going to be a factor?
Nope.
What does it have to end? What has to be in the ones place?
0.
There has to be a 0 in the ones place for 10 to be a factor. All right, how about 11?
Nope.
No, it has to be the double.
Yeah.
Double.
So 55 would be 11 times 5, but that's 2 away, so that would not work. We found earlier that 4 times 12 was 48. That's as close as we can get. 5 times 12 is 60. So we can say that 53 is what kind of number?
Prime.
Prime. It's a prime number. The only factors of 53 are 1 and itself. So it's a prime number. Is 62 going to be a prime number?
Nope. Because it
How do you
has
know?
2.
Yeah. So what does that mean it has 2?
It's even, so that means it's gonna be composite.
Yeah, it's an even number. All even numbers are composite because if it's an even number, it will have 2 as a factor. If all even numbers are composite, does that mean that all odd numbers are prime?
Nope.
No.
There's
No.
some that aren't.
Yeah, there's only 2.
There's some odd numbers that are prime, but certainly not all odd numbers are prime. How about 21? Is 21 odd or even?
Odd.
21's an odd number. Is it prime?
No.
Yeah, 7 times 3. So there's an example just like that right off the top of my head. All numbers that end in 5 are odd, but they have factors of 5. Okay, so we can always know that an even number is composite, but some odd numbers are also composite. All right, so let's look at the factors of 62. What are we going to start with?
1 and 62.
1 in itself. So 1 and 62. All right, and we said it was even, so will 2 be a factor, Maggie?
2 and 31.
If 62 is an even number, will 2 be a factor? Okay, Tatum, what is it?
31.
How did you know it was 2 and 31?
I knew it was 2 and 31 because 3 plus 3 equals 6 and 1 plus 1 equals 2.
Yeah, so if you have 62 or do 62 divided by 2, that would be 31. All right, is 3 going to be a factor?
Nope.
We found earlier that 3 times 20 is 60. What if I did 3 times 21? What would that be? 63. And 63 is too much. So that would not be a factor. How about 4?
Nope.
Okay. We said earlier we did 4 times 13 was 52, but that's still 10 away. How else could I tell besides using multiplication? Well, we could use division. What would we divide, Ainsley?
62 divided by 2.
Yeah, if we're testing to see if 4 is a factor, we would do 62 divided by 4.
Put 6 into 1 times and then put the 2 in the 1.
Okay, so Bryce said we could put
4 into 1. 2.
let me. Okay. 6 things can go into 4 groups one time. We would have 2 left over. So that 2 gets regrouped to the 1. How many times can 22 things go into 4 groups?
4 times 6.
4 times
Equals
5.
4, so 5.
5
5,
and
very good.
Remainder 1.
5, remainder 1 or remainder 2?
Yeah, 2.
Remainder 2. Bryce said that he knew 6 times 4 was 24. That was too much, so he had to go back to 5. 6 times 5 is 20. So that gives us a remainder of 2. So we know 4 will not be a factor. How about 5?
No, because
Nope.
it doesn't end in 0.
It doesn't end in 0 or 5. 6.
No.
6 times 10 is 60.
And then
6 times 11 is 66. So that would not work. 7.
Nope. 7 times 9 equals 63.
7 times 9 is 63. Very good. So that would not work. All right. 8.
Nope. Because 8 times 8 equals 64.
Okay. Yeah. 8 times 7 is 56. Then 8 times 8 is 64. So that's not going to work. 9.
Nope.
6 times 9 is
9 equals 30.
And
63.
54. And then if we go up to
7.
7, that would be 63. And that's 1 off. So that's not going to work. 10.
Nope. And then it was 0.
Doesn't end in a 0. 11.
Nope. Then it's the same number.
It's not the same number. It's not 66. So that's not going to work. All right, 12.
Nope.
We said earlier that
It's 60.
5 times 12 is 60. That's as close as we could get. So we can say that 62 has 4 factors. 1, 2, 31, and 62.
Now it's better.
Okay. All right, so now we have 67.
Knocking. It's
67 is an odd number or an even number?
Odd.
It's an odd number. So do we know for sure that it's composite?
Nope.
Do we know for sure that it's prime?
Nope.
No, you're going to have to see what we can figure out. All right, so we know we can start with what numbers?
1 and 67.
1 in itself. So 1 and 67 definitely are factors. It's an odd number, so is 2 going to be a factor?
Nope.
Nope. Okay, how about 3?
Nope.
Okay. We know we found earlier that 3 times 21 was 63. If we went up and did 3 times 22, that's going to be 66. And we're still 1 away. So 3 is not a factor. How about 4?
Nope. Because 4 times 14.
Okay, so if I divide by 4, if I did 67 and I divide by 4, I can put 6 things into 4 groups once. I have 2 left over. I can put 27 things into 4 groups. How many times?
1.
If I'm doing 27
Oh.
divided by 4.
5. With a remainder of
4. No.
Alright, so
6.
alright, so 6. Bryce says 6. 6 times 4 is 24. How many would I have left over?
3.
I'd have 3 left over, exactly. So I know that 4 is not a factor. How about 5?
Nope. It's not 5 or 0.
I don't have a 5 or a 0 in the ones place. Okay. 6.
Nope.
6.
6 times 10 equals 60 and then 66.
And 60 and then 66 would be 6 times 11, so that's not going to work. 7.
Nope. 7 times 9 equals 63.
Okay.
Another 7 would be 80.
Yeah, so if we did 7 times 9, that's 63, then we would go to 70, so that's not going to work. Alright, 8.
Nope. 8 times 8 equals 64.
8 times 8, 64. That's as close as we could get. We just did 9. 7 times 9 was 63, so we know that won't work. 10
Nope.
doesn't end in a 0. 11, it's
Nope.
not a double. It's not 66. 12.
12 times 5 equals 60. And then times 6 will be 72.
Okay, very good. So we know 12 is not a factor. So what kind of number is 67?
Prime.
The prime number, another prime number. All right, how about 74? Will 74 be prime or composite just by looking at it, Sky? Will 74 be prime or composite? Do you agree, Jaden? Tommy, do you agree?
yes.
Jeremiah, do you agree?
Nope.
Defend your answer.
2 times 37 equals 74.
Yeah, it's an even number. If it's an even number, can it be prime?
Nope.
No. So we know we can start with 1 and 74. Okay, let me click those here. 1 and 74. Jeremiah told us 2 and what, Jeremiah?
37.
How did you know it was 37?
7 plus 7 equals 14. And then you add the 1 to the 10th place, and then 3 plus 3 equals 6. Add the 1. I mean the 10, then
Okay.
7.
So you used kind of what you knew about multiplication to figure out what you would need? Okay. All right, to half it, you could also use division. A couple different ways that you could do that. All right. So we've got 2 as a factor, 2 and 37. Is 3 going to have a factor of 74?
Nope.
3 does not have a factor of 74. How about 4?
Nope.
5?
80.
Doesn't end in 0. 4, 5. 6?
Nope.
7?
Nope.
8?
Nope.
9?
Nope.
10?
No.
Nope, doesn't end in a 0, so I know 10 won't work. 11?
Nope.
See,
Double.
66 and then 77, so that wouldn't work. 12?
Nope.
Nope. All right, so
2 off.
74 has 4 factors. 1 and 74 and 2 and 37. Okay. Now we have 80. How many points was this worth? 22. And we found 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 factors. So how many factors are there going to be of 80?
10.
10 factors.
That's a
All
lot.
right, so here we go.
Yeah.
What's the first set of factors?
180.
1 and 80. We know that's about as easy as it comes to find.
You're at least gonna get.
So I have 1 and 80.
You're at least gonna get 10.
2 and what, Callie?
40.
2 and 40. How did you know it was 40?
Because 80 divided by 2.
Yeah. Okay, very good. All right. 40 plus 40 equals 80. That's another.
Or you
All
could
right.
go just add the, 4 times.
Oh, I
4
clicked the wrong
plus 4
one.
equals 8, then add the
4
0.
times.
Okay. All right, so how about 3? Is 3 going to have a factor of 80?
No.
I can't divide 80 into 3 equal groups. I can quickly test
90.
by doing 80 divided by 3. That would be 2. I'd have 2 left over. Closest I could get was 3 times 6 is 18. So I'd have a remainder of 2. I know 3 is not a factor. Is 4 going to be a factor?
40 times 2. Well, it's the same thing as.
Yeah, 4 times 20. And you could use what you knew about 2 and 40 to find those. Okay.
You just replace the 0 with the 3.
All right, so we've got 4 and 20. Will 5 be a factor of 80?
Yes.
16.
Yeah, it ends in a 0. Okay. How did you know it was 16, Sky?
Because I was counting by 5.
Counted by 5 16 times to get there. All right. So we've got 16 and 5. Is 6 going to be a factor of 80?
No.
No, I can test quickly by dividing 80 divided by 6. That goes 1 time. I would have 2 left over. 20 doesn't divide equally into 6, so I know that would not work. How about 7?
Nope.
I can do the same thing. I can divide quickly. I know I would have 1 extra. 8 goes into 7 1 time. I would have 1 extra, but 10 does not divide equally into 7.
It'd be over because
Okay.
it'd be 84.
So now we're to 8.
Yes.
8 times 10.
As easy as you can get.
That one's almost as easy as 1 and 80, isn't it?
Yeah.
Okay. So we know that we need to check 8 and 10. Will 9 be a factor?
No.
How do you know that 9's not a factor?
9 times.
What, Ainsley, what do you know? Yeah, 9 times 9 is 81. So there's all of our factors. 1, 2, 4, 5, 8, 10, 16, 20, 40, and 80. Okay? Time consuming to find all the factors? Yes. Hard?
No.
No. Does it make it a lot easier if you know your multiplication?
Yeah.
Absolutely.
You gotta do some subtraction and stuff.
I mostly do multiplication.
All right.
Addition? Yeah. I do it in my head.
Next, we have some rounding.
Easy.
We're rounding the number 119,538 to the nearest hundred. What digit do I have in my hundreds place value, Jaden?
500.
I have 5 hundreds. Where do I look to see if that 5 goes up or stays the same? Where do I look, Sky?
The hundreds.
I'm rounding to the hundreds, so where do I look? What tells me if that 5 is closer to 500 or closer to 600? The 10s.
There you go.
I have 3 10s, so that's below the midpoint. It'll be closer to 119,500. Okay. I'm rounding to the thousands now. In my thousands place value, I have a 9. I have 119 thousandths. Where do I look to see if 119,000 stays the same or goes up to the next thousand, Brady?
500.
The 500. What does the 500 tell it to do?
Go up.
Go up. So what's the next thousand going to be, Aiden? What would 119,538 round to the nearest thousand? That 9's going to go up to 10,000, which will make it 120,000. Okay. Now I need to round to the nearest 10,000. I have 11 10,000s. I'm going to look at that 9. Is that 9 closer to 119,000 or 120,000, Zyla? So I round 119,538 to the nearest 10,000. Am I leaving it at 110,000? Or do I need to go up to 120,000? It's going to go up to 120,000. So I have a question. Rounding to the thousand and the 10,000s place value gets me the same number. Why, Tatum? Yeah, so exactly. That 9, since the 5's telling it to go up, the next 1,000 is 120,000. And that's the same with the 10,000s. That 9 tells that 10,000 to go up. All right. Let's go on to this next one. All right, next we are dividing by powers of 10. Now, when I divide by 10, what happens to my place value?
It gets 10 times smaller.
It gets 10 times smaller, so it's going to go down, right? It's getting smaller. So if I go from 10s, I would go down to the 1s. If I'm at hundreds and I divide by 10, I would go down to the 10s. Okay, so we have 120 divided by 12 equals 10. Then we have something divided by 120 equals 10. Now this is just me. This is the way my brain works. It's easier for me to see it as multiplication than it is division. So I'm just going to turn this division fact around into a multiplication sentence. So I'll say 10 times 120 equals A. All I've done is taken that same problem that I have as a division sentence and I'm making it into multiplication. What is 10 times 120?
1,200.
1,200. So what does A equal?
1,200.
Yeah, 1,200 or 1,200. Okay, so then this next one, I'm dividing again, so I'm going to go ahead and turn that around. I'll have 100 times something equals 12,000. Okay, so if I am looking for 100 times what number gets me 12,000, I know I'm going to have to do 1 times what to get 12? 12. Now I can take care of my zeros. I know I have to have 12. 1 times 12 is 12. I have 2 zeros in my factors. I need 3 zeros for the product. So what do I need to add? How many zeros do I need with that 12? How many, Scott? 1. So my answer is 120. B is equal to 120. All right. Last one. I have something times 1,200 equals 120,000. What number times 1,200 equals 120,000. All right, so I'm going to ignore the zeros. What number times 12 is going to equal 12?
1.
1. So I know I just need a 1. I have 2 zeros. How many zeros do I need?
2.
My product has how many?
3.
How many is in my product?
3.
120,000 has how many zeros? It has 4 zeros. So how many more do I need?
1.
I have 4 in my product. 2 of them are taken care of with this factor. So how many does that leave me?
3.
2 more. So that's going to be 100. All right, next you have an input, output, or function table. So if I make a function machine, what's going to be my rule? I know I have 10 in. If I put in a 10, I would get out 100. So what's my rule going to be? How do I get here?
You're adding another 0.
Which would be multiplying by 10. Okay, so if I drop in 1 and I do 1 times 10, that would get me what?
10.
A is equal to 10. What would I need to drop in so that if I multiply by 10, I would get 50 out, Jace? 5. Okay. Then we already have 10 and 100. If I drop in 15, what would come out? 150. All right, the next question asks you what the rule is for the table above, and that rule is times 10 or multiply by 10. And then the last one, we're converting yards to feet. It takes 3 feet to make a yard. So 7 times 3 is what, Callie? 21. A is 21 feet. And then 15 feet equals how many yards? I have 15 feet, so I need to divide by 3, and that's what, Maggie?
5.
5. Very good.